Okay, now that you've watched the first video where I talk about the main concepts and the main idea behind simulation, let's work on an example. This is the one we did in class, but by popular request, I'm creating a video of myself doing it beginning to end. This way you can follow along at home or at a bar and go slowly, pause when you need to, and fully understand what's going on. This is the first example in lecture 9, so it's that Arc'teryx company. You have the problem statement with you. The idea is they have these employees making demand estimates and they want to use that knowledge somehow to run the simulation. So the idea is we have this variability in demand. We're going to try to capture it using what they're calling a truncated normal distribution, because this is what they believe captures well the variability. That's to say, the demand is never going to be below some value, never above some other value, and in between those two, it will have more or less a nice bell curve shape. So for this normal distribution, we're going to need to know what the mean is, what the standard deviation is, and what's the minimum and maximum value. We can simply do that by using the obvious choice, which is to calculate the mean, standard deviation, and min-max from these 12 values the employees gave us. So let's do that. Average of these values. The standard deviation, ST_dev, of these values. And min and max. All right, now let's go over here and calculate what we need to be able to get the profit number at the end. The whole point of the problem is to figure out what would be a good production quantity. I don't want it to be too low because then I would miss demand. I don't want it to be too high because then I will be left with a lot of jackets that I need to salvage, and that hurts my profit. So the problem statement says let's begin with 7,800. See how that goes, and I will change it. Now the realized demand is the random number we're pulling out of this truncated normal distribution. So to obtain numbers from a distribution like that, we're going to use the formula from the SimVoy add-in, rand trunc normal. So all of them begin with the rand word, and trunc normal for truncated normal. And the parameters are what's the mean first, comma, what's the standard deviation, comma, what's the minimum value, comma, and the maximum value. All right. Now you see that this is giving you a fractional number. What we can do is round this number to the closest integer by surrounding this with a round function. And at the very end, instead of just closing the parentheses, I put comma 0, which is telling the round function to round to the closest integer number. Here we go. Now units we sell. The units we sell will depend on both the production quantity and the demand, and it's actually going to be the smallest of the two. If I make too much, what I sell is the demand. If I make too little, what I sell is what I make. Units salvaged, right? Well, if I make more than demand, the salvage will be positive. If not, the salvage will be 0. So I simply put here what I make minus the demand. If that number is positive, I want that number. If the demand is greater, that number will be negative. And what I want really is to say there was nothing salvaged. So to capture this idea, what I want is I want the maximum between what I made minus what the demand was and 0. Because again, if I made more, H6 minus H7 is positive, there is salvage. So I want that value as the response because that's greater than 0. But if H7, the demand is higher than what I made, that difference is negative. And all I want to know is that, well, then salvage is nothing, right? So maximum does that for me. Production cost, that's going to be however many units I make times what it costs to make them. Cost per unit 80, right? So 80 times the quantity Q. Revenue from sales will be, well, how many did I sell down here times what I sell them for, 100, right? Revenue from salvage, how many units get salvaged times what I make when I salvage them, 30. So the profit will be the two revenue amounts, revenue from sales plus revenue from salvage, minus the two costs, the variable cost or production cost minus also the fixed cost. Okay, great. So now we are ready to run the simulation. Notice if I press F9 on Windows or Command =sign on the Mac, that will make the cell where I have the random function, trunc normal. Each time I press, it creates a new number there. And depending on what that is, it will affect my result, right? So notice it's less than the production. There was salvage value, units sold was the minimum, and so forth. And in this case, in this particular scenario, I am losing money. I can go to another scenario in which now I'm making money. So what I want to know is I want to change the value of H7 many times and record the value of H13 many times and see what that looks like in terms of a graph, of a histogram. So let's do that. So bring up the simulation add-in, Option Command V on the Mac, Control Shift V on Windows. So you're going to see this screen. What do you do there? Okay, so the output value cell is the main output you're looking at, profit for us. If you want to look at other outputs and record what's happening to them, because they're also important, you can list them here under the information cells part. For us, let's also look at the demand, and we'll see why in a minute. It asks you how many trials you want to run. The default is 10,000. It's a little bit too much for this exercise. Let's just do 1,000. The other thing I wanted to check is to check this box that says cumulative charts. I'll tell you what those do. If we run this now, we wait a little bit. It tells you prepare to wait. It's not that bad. Just click OK. And wait, and it's going to produce 2 new tabs for you here. Okay, let's wait. Now it's finished. The first one is called simulation data. What is that? Remember that we asked to do 1,000 trials. So it's going to list for me here 1,000 rows. So if I scroll down, this is going to go all the way to 1,000. Right? And for each of these rows, it's going to tell you this was the demand that I pulled out of the random distribution of demands. And for this value of demand, that was the value of the profit that came out on the other side of the model black box, if you will. Great, so I feed this, I get that out. I feed this, I get that out. Okay, this is what this is showing you. The most important tab is actually the other one, which is the summary tab. So let's read what this is giving us. First, in this top left corner are some summary statistics of both the profit and the demand because we were tracking both of them. So here it says the mean profit was 48. So let me copy that to the main sheet down here. And it says that the mean standard error, right, that is the standard deviation of the mean, was 947. If I go on here, the standard deviation of the outputs, right? Now notice, this histogram here is the histogram of the outputs. There's a lot of probability in this particular value here, but there's a little bit of probability in some of the other values, all the way to what? A big loss of $137,000. So that loss is possible, all right? And the maximum profit you make is $56,000. Now remember, we talked about percentiles, right? In this part here, you're going to have the percentiles going from 0 to 100, but in jumps of approximately 5% each time. And sometimes you want to have access to a more fine scale of these percentiles, because what if I want to know what is the 7% percentile? I can't see this here, right? I only have a 5 and a 10. So because we clicked that box that says cumulative charts, we have a finer version of this all the way on the right hand side here. Okay, so if I want to know now, for example, what is the chance that I will lose money, right? Have negative profits. So these are the profits. If I scroll until I see the closest value to a 0 is here. What is the chance of that? I have a 5.5 roughly % chance of having negative profit. One of the questions in the lecture note is, what is the chance you will lose more than $100,000? So I can scroll until I find negative 100,000 on the profit column, more or less here between this and the next one. That chance is about 1.4 or so %. So here, the probability of negative, less than 0, and the probability of less than minus 100,000, I think it was 1.4%, and the other one, even though I just said it, I forgot. I think it's like 5.5. 5.5. So 5.5%. So let's create the confidence interval for this mean. Because now I see, okay, I expect to make $48,000, but how confident am I about that value, right? So if you remember the norm ZIM we talked about, right? For the 95% confidence, and just out of curiosity, if you wanted a 99% confidence, the value would be the following. Remember the 95%, I want to see throw away 2.5% on the right hand side. So from that cutoff point to the left, I have 97.5% probability left. That's my roughly 1.96. And if you wanted a 99% confidence, you're going to have to the right of the cutoff point a half of 1%. So what's left in terms of probability to the left-hand side of the cutoff point is 99.5%. So that's the 257 I told you in the other video. So let's make a 95% confidence interval. That's going to be the low end is going to be the mean, right? Minus my 1.96, and let's anchor that number, times the mean standard error, or the standard deviation of the mean, which is in C16. And the high end of the confidence interval, the mean, now plus this 196 times the standard error. So now what this means is the following. If I were to run the simulation 1,000 times, okay, and for each of them calculate a mean value, 95% of those, or 950 of the 1,000 times, I would see a mean value that is between $46.2 thousand and $49.9 thousand. This is how confident I am about this particular mean value. Okay, great. So we saw this result when we chose 7,800. Why did we choose 7,800? It's arbitrary. And then there was a dude that says, oh, why don't we just use the mean? That sounds like a good value. All right, let's try and see what that does. So let me go ahead here and change that to 12,000 and run again. But now I have to be careful because remember, I told you earlier, each time we run the simulation, it's pulling random demand values from the demand distribution. And if I just run the simulation again as I did the first time, what's going to happen? In the data tab, it's going to pull up 1,000 different demand values. Now, once I run that simulation with a quantity of production of 12,000 units, I will not be able to tell if, well, the results will be different from when I run with 7,800 production of jackets, but I will not be able to tell if the difference was because I changed from 7,800 to 12,000, or if the difference was because the demand, the 1,000 demand numbers that I input were different. Probably it's a combination of both. But what I would like to do is isolate how much of that difference of the two simulation results was caused by my changing from 7,800 to 12,000. Because that's the whole point, to know whether or not the 12,000 is better or worse. So what I really want to do is I want to subject the 12,000 production quantity to the same 1,000 demand scenarios. And to do that, I'm going to take advantage of the fact that when you run a simulation, the random numbers that come out of it are influenced by what's called the seed. The seed is the initial number you give the random number generator of your simulation software, and that particular seed will fully determine the order in which the random numbers will be generated. So if I feed the simulator the same seed to start with, the random outputs it produces will be the same each and every time. If you want variability, then you just run the simulation without changing the seed, because each time you pull up the simulator, it throws in another seed that's different from the previous seed. So for here, let's just copy this seed here, and you can copy whichever one pops up in your computer. Go back to the simulation and bring that up again. And I want to paste that seed that I copied here. Okay. So when I run this simulate again, remember that I also changed the 7,800 to 12,000 before I did all this. When I run that again, if everything goes well, we should see the following. I'm going to wait for it to finish. Okay. Good. So I am clicking on the simulation data of the first simulation, all right? Look at the column C of values. Now I'm going to click on the simulation data of the second simulation. Pay attention to column C. When I click there, you see that it's exactly the same. Again, that's because I fed the simulator the same initial seed, so the random numbers will be the same. And why is this useful? Because I want to isolate the effect of the change that I made. This change here from 7,800 to 12,000. I don't want different demand inputs to confound my results. So now let's look at the summary of the second run. If you recall from the first run, look at this histogram here. You almost see no bar because they're very low profile here in this big bar. Second simulation, notice that the other bars start to become a little taller. So there's less probability in this top result and more of it is being spread down the line here. Let's look at the mean and standard deviation. So now I have a 43,997 mean profit. It's a little worse. When you go here in standard error, you see that it's almost 4,000. That's quite worse than the previous one. And when we look now at what is the worst that can happen, now there's a potential loss of $347,000. Terrible. Now, let's look at those probabilities. What's the chance I'm going to lose money? What's the chance I'm going to lose more than 100,000? The 100,000 chance will be between these two. So roughly almost 16%, right? 15.9%. I can put that here. 15.9%. And the chance of going negative, right? Let's see, find that where the zero is, more or less between these two, right? Chance of negative is roughly 30%. So 30%. And let's calculate the confidence interval, but because we put this formula here like we did before, I believe that if we just copy that down, we get it. Now let's compare these two choices of production quantity. Well, I think it's pretty clear that the 7 is much better, right? Because first of all, the mean to begin with is higher. The confidence interval is narrower, so from 46 to 49 as opposed to from 36 to 51, much wider here. Plus the chances of bad stuff happening are much lower in this 7800. 5.5% of losing money versus 30, and 1.4% chance of losing more than 100,000 versus 15. Of course, if we want to look at the upside, what's the upside of this model here is probably better than the upside of the 7800. Let's see. The 7800, the highest it goes is 56,000. So let's see, what is the chance of making more than 50,000 in the 7800 model? It's approximately 9.5%. In the 12,000 model, going higher than 50,000, the chance, sorry, I did it wrong, right? 9.5% is the chance of being less than or equal to 50,000, which means the chance of being more than 50,000 is 90.5%. It's the other way, right? So this number here is what is the chance that the result is this value or less. But I want to know the chance of being 50,000 or more. So if it's 9.5 of being less, then it's 90.5% chance of being more. In the 12,000 quantity simulation, here, when I go to the 50, I have a 37% chance of being less, and I have the complement, 63% chance of being more. So it's actually even worse in that regard. Okay, the 12,000. Okay, so sounds pretty clear the 12 is much worse than the 7. Notice, the 12 is the average. So one more evidence that there are situations where going with the average of what you expect to see is a terrible idea. And that's a perfect example of that. Right? 78 is way below the average and gives you more results. Not more, gives you better results. Now, the last thing that the question asks you to do is to check, could you zoom in on a even better value of Q by perhaps using solver? And here's the idea. I could look at this data, and I know that for me to be consistent, I have to look at the same 1,000 demand scenarios. And I could look at these and say, what if I were to calculate these profits? So I can make my quantity be a variable. So the quantity I'm looking for will be a variable for me. So this is now a solver model. And the average profit will be my objective function. So I want to ask solver, find me a Q value that maximizes the average profit over these 1,000 demand scenarios. All right? So first thing I'm going to do is I'm going to calculate 1,000 profits. Then I'm going to put their average here. So if I put the profits in column D, their average, I can do just the average formula of those values there. So let's do that. So what I'm going to do in this cell here is essentially the exact same calculation we had to calculate this profit here originally, but instead of splitting into its several pieces and then combining the pieces in this cell, I'm just going to have all of the pieces together in a single formula. Here goes. I make $100 for every unit I sell. But how many do I sell? The minimum between the demand I had and the quantity I produce. I'm going to anchor the quantity because it's the same quantity for all formulas. Plus, I also make money when I salvage. It's $30 times the number of salvaged units, but that's the maximum. Remember, if you forget where these are coming from, go back to the Arc'teryx tab and you will see the maximum between how many I make dollarized minus what the demand is, comma 0. Because if that difference is negative, it means there's no salvage. So I want 0 to be there. What are my costs? It's $80 times how many I make. That's my quantity Q that I'm going to ask solver to look for, dollar, minus the $100,000 of fixed costs. Notice the following. If I go in the yellow and put 12,000, the value that appears here in D2 matches the value that's here. Why? Well, because the calculation that I just performed is exactly the same calculation the simulation was using. Now, when I take this and copy down 1,000 times to the 1,000 rows by double-clicking here, all of these 1,000 values of profit should match these 1,000 values. Reason being that these were calculated when Q was chosen to be 12,000, and I have temporarily chosen it to be 12,000. The question is, can I find a number for the yellow cell that will make this average go higher? So currently, the average is from D2 all the way to D1001. Look at this number, 43,997. Let's see the answer on the previous simulation. 43,997. Again, why is it the same? It's because I'm simply averaging the same 1,000 profit values, because I still have a 12,000 here. Now let's go into data solver and ask it to do this. I want to maximize this average in J7 by changing this cell here. I don't need any constraints. Make sure down here you choose a non-linear solver, because there are lots of non-linear formulas in this model, like minimums, and sometimes there are ifs, maximums. And solve this. Wait a little bit. Great. So now this is not guaranteed to be the best, okay? But it's brought us to a place that looks pretty good. Let's take a look. So 98.59 is the answer. I'm going to go back here and say solver proposes 98.59. How good is that? I have no idea. Let's check it. It's telling me the average profit will be 63,026. So 63,026. Great. But that's a single number. Even though it's considerably higher than the others, it's over a 20% increase. So the percent increase is what? Let me take this, divide by that. 31% better. But how does it fare in terms of the spread, right? Because again, the whole point is, I don't want a single number. I want to know how this number appears in a distribution. Maybe my chance of losing money is gigantic, even though my average is high. So to be able to tell that, what I'm going to do is I'm going to take this solver suggestion 98.59, put it here, and then run a third simulation, out of which I can get values like this, and then I'll be in a better position to compare against the previous two. Once again, we're going to save that seed because we want to isolate the effect of the change. So let's do that. Again, remember that I changed this to the solver suggested value, which mine is not necessarily going to be the same as yours. Let's do the simulation again. Paste that seed value back here. And simulate. You'll see a third collection of two tabs appear down there. And we're going to do similar analysis. This is the mean. We already had that, but we can paste it because I forgot to put the cents in there. Not that it makes that much of a difference, but... And then I'm going to take the standard error. Notice a little bigger than the 7,800, but not as bad as the 12,000. So my confidence interval, I can already calculate. It's reasonably narrow, from 58,000 to 67,000. Completely, there's not even a intersection of these confidence intervals. So I'm way, way better in terms of the expected profit. No doubt about it. Now let's see my chances of losing money and my chances of losing a lot of money. How do I fare there when I make this third choice? Just go to the rightmost percentile table. Chance of being less than negative 100,000, around what? 5.8%. So here, 5.8%, and chance of being negative about 15%, right? Let's go here, 15%. Now this has become a little less obvious for the following reason. I think it's still obvious that the 12 is a pretty bad idea. But now if you look at the 7,800 and the 98.59, this is a call that you have to make. Are you okay with going up in profit by 30%, which is gigantic, if the cost of that is going from a 5.5% chance of losing money to a 15% chance of losing money, and going from a 1.4% to a 5.8% chance of losing a lot of money. And even though it's not obvious what to do now, I think it's nice to know that these chances exist and their magnitudes, because at this point you can bring other people into the conversation and talk to them about this and see what kind of risk are we willing to take based on the rewards that we could get on the other side. All right? So I hope this video has been useful and that you can watch it at your pace and better understand what we were trying to accomplish in class. And hopefully when we do this again with more examples on Tuesday, that it will be less confusing and more enjoyable. I'll see you guys then.